Okay, in the last video, we studied how we can apply the amortization method to pay off a loan. So essentially there, in most cases, we apply a level annuity immediate to pay back a loan. Okay, occasionally for some difficult questions, the payments may not be level. We did one example in which uh, the the annual payments or the monthly payments actually grow by a fixed amount. So we are essentially, applying an increasing annuity there. But in most cases, we will do a level annuity. That's the standard amortization. In this video, we are going to study a second method. It is called the sinking fund method. Uh, Behind this method, it's a basic idea. So in this basic idea, there are two parts. Part one, at each period, I will pay the entire interest. So no matter how much the loan accumulates interest over a certain period, say 1 year, I will pay that off first. Okay. Since I pay off the interest, my loan amount or my balance never grows or never decreases. Right? It stays at the same amount. I only pay off the interest. That is part one. In part two, I will make regular deposits into a fund. Okay, this particular fund is called the sinking fund. I will use this fund to eventually pay off the entire loan, meaning by the end of a certain period, say let's say by the end of the maturity, right? So when you take out a loan, there's a term, let's say 10 years. So by the end of 10 years, my sinking fund will accumulate exactly the loan amount. Okay, let's say $10,000, right? Since I have exactly the amount to pay off the loan, and that's the end of the business, right? I paid interest throughout the entire 10 years, and by the end of 10 years, I have $10,000 to cover exactly the loan amount. That's job done, right? So that's the basic idea behind the sinking fund. As you can see, they are quite dramatically different um, properties, right, between the amortization and the sinking fund. Remember, under the amortization, the principal or the running balance, the outstanding balance, is actually reducing, right? Because for every single payment, it not only pays off some interest, but also pays a little towards the outstanding balance, right? And the portion gets bigger and bigger towards the principal, so that eventually it reduces to zero. Okay, but here, we apply a different idea. The idea here is to pay off the interest each time, so that the outstanding balance is the same, remains the same, and then I make another deposit into a separate account or into a separate fund. I will rely on this particular sinking fund to accumulate enough money to cover the original loan amount by the end of my term. Okay, so that's the principal idea. Let's introduce some notations. That's actually the same. Let L be the loan amount, I be the effective interest rate per period. This is the interest rate on the loan. Okay, the interest payment, often we call it the service payments. It's obviously the original loan amount times by the interest rate, right? So that's that part is obvious. Just somehow, maybe remember this this term is called service payment. Remark, this remark is very important. Here we actually have two interest rates. The first interest rate, the standard I, is applied on the loan In other words, this is the cost of borrowing, right? I is how much you pay to the lender, okay? And J is how much you earn on the sinking fund. Remember, under the sinking fund method, you actually make deposits into a fund. Of course, right? You make deposit because it gives you interest. Those two interest rates may be different, okay? And we will see when they are the same. Well, it actually, the sinking fund method is nearly the same as the amortization. The difference starts when I and J are different. Now let's derive some important formulas under this method. The first actually we already did, right? So the service payment, which is also the interest. So this is the interest per period. Obviously, it equals the outstanding balance, which is L. It does not change under this method, times by the interest rate I. So I is the interest rate for the loan, okay? The next one is the sinking fund payment. Here I mentioned under the basic idea, right? I will need to make regular deposits into a fund, okay? In the end, I would like to have this. So let's denote the amount of regular deposits to be X. So here's the key. Let me put it in blue. So this is actually J. If this equality holds, my sinking fund will be able to accumulate exactly the loan amount by the end of n years or n periods. So from here, we easily see that X would be the amount I should deposit each period. Okay, n obviously is the number of years or number of periods. So far, I think things are quite easy, right? Sometimes, occasionally, we also want to know the net amount of sinking fund loan. So let me type it. This has the same sense as the outstanding balance, but of course they are not exactly the same. Net amount of sinking fund loan. So we always assume, okay. So let me put a basic assumption. So a standing assumption, unless otherwise stated, we always assume this. That is the service payments equal interest due. Okay, so that the balance L does not change. So that's a standing assumption we always assume. So I don't want to type it again. How can we derive this? So first, let me write it down. So let's use NT and NL. That's a textbook. Give any notation, because I don't want to write net amount of loan. So let's call it NL. Okay, N stands for net, L stands for loan. So net amount of sinking fund loan at time t would be equal to L minus SFP. Okay, so SFP is X, okay? Okay, so what we have is this basic idea. All right, so basically each payment is X. In other words, it's SFP if you want to write it in. Okay, so this is what we define as SFP. Right. we directly use L minus it. That's because we always pay interest at each period. So the loan amount does not change. It's still L, right? Previously, under the amortization method, we would use L times. So let me use another color. Right? Remember, under the amortization, what we do is L BT equals L times 1 plus I to the T's, right? So the original loan amount grows from L to L times the accumulation factor by the end of T, right? And then you minus X times, right? So the different part is here, right? Originally you have this accumulation factor, but under the sinking fund, it's simply L. Again, the reason is because we pay off the interest each time. So the loan amount does not change. Otherwise, it's the same, right? Except we put a new notation. We put SFP instead of X, but that's just the notation, right? Here I also use X. You can put X as well. So in that sense, it's the same. Of course, there's a different way to calculate the net amount as well. If you want to do it in a separate analysis, we can do it later, because now what I assume is the interest is already paid off, right? And if you do something similar to amortization, you will need to minus the interest payment. We will see that later on. For now, let's do a question. By the way, let me summarize the payment. So what is the payment? So at each time, since the payment is the same, the amount of payment is equal to two parts, right? I have the service payment plus the sinking fund payment, right? So there are two parts that comes from my the basic idea here, right? So for each payment, I divide it into two parts. Part one is used to pay the interest only, so that the loan amount does not change, or the balance does not change. The second part is used to contribute to a sinking fund, okay, which might accumulate at a different interest rate J. So that's why whenever I deal with the sinking fund, I will use J as the interest rate. But in order to calculate the interest of the original loan, I will need to use interest rate I. Okay, so that's the key part. I made a mistake for the amortization. Okay, for the amortization, there is no J, it's I. So that's a mistake. So let me put it back. Blue. So here's I. Okay, because under the amortization, there's only one interest. Okay, now let's solve an equation. Let's solve a question. It's arguably sinking fund method is easier than amortization, because the balance is the same, right? Saves you a lot of time. The interest is always the same. So here we have a loan of 6,000 repaid annually over 7 years. So it's 7 annually using the sinking fund method. Interest is charged at the effective interest rate 10%. Money is invested in the sinking fund at the end of each year. And this money earns interest rate at 8%. So in this question, I and J are different. So first of all, I can easily calculate the interest, which is equal to the service payment, and it's the loan amount times the loan interest. It's 6,000 times by 10%, so it's easily 600. Okay, that part I already know. Now let's figure out the sinking fund payment. the sinking fund payment times the accumulated value of the annuity, level annuity of 7 years at 8%, right? I want this sinking fund to accumulate $6,000 by the end of 7 years. So from here, I can get SSP to be $672.43. Okay, now I can claim each payment would be equal to the service payment and the sinking fund payment. So it's over 1,272. Okay, so that's sinking fund method. It's a lot easier, right? So this is fixed. Pretty much everything is fixed, right? So it's the only thing that is not fixed is the value in this sinking fund, right? Because each year I will make this deposit, and each previous deposit will earn some interest at 8%. So this sinking fund is growing. Other than that, everything else is constant, right? So that's why this is actually a lot easier than the amortization method. So here we change J to be the same as 10%. And then we will discuss what would be different. Okay, service payment is the same because we don't change I, so it's still 600. And now I do the same calculation. I will get my the sinking fund payment to be smaller. Now it's 632.43. Well, it obviously should be smaller because now my sinking fund is earning 10% instead of 8% because I can earn at a higher interest. I can reduce my deposit in order to reach the same goal because now I can earn more. So the payment now would be, adding them together, is $1,232.43. Okay. Now, under this, what would be the amortization method? What would be my X? My X, well, it doesn't matter what you put because there's only one interest rate. So if you do the computation, let's put Y, okay? You will get this is exactly the same. So if I and J are the same, the two methods are the same, okay? Because what you put in the sinking fund, it thinks that they earn the same interest rate, right? And so let me type it here. So when both interest rates I and J are the same, the two methods give the same. Okay, so essentially there is no difference. The reason it's naive. All you need to do is to analyze a $1 loan, and you will see that. So for instance, assuming okay, for amortization, I write it here. So consider one loan, okay? So the unit size. So obviously, so let's use Y for that. Right, this is easy. This is the amount you need to pay if you applying the amortization. Okay, compared to sinking fund. So here we know that your SFP times by your, so since J equals I, so I put I here, it is also 1. So I know FFP equals 1 divided by the accumulated value. And also I know the service is I 1 times I, so equal to I. So now the question is, I claim they are equal, right? So let's prove that. Well, where do you want to go? Let's start from the sinking fund. So adding them together, so here would be 1 plus I to the nth minus 1 divided by I. Or you can so finding the common denominator. So obviously this cancels this. Okay. Now let's divide this guy over. So let's keep I first. Divided by 1 plus I to the nth. So this becomes 1. This becomes 1 plus I to negative n, right? And then we divide by I. Right. So you see, this is exactly 1 over a n. So my conclusion is correct, right? So given I and j are the same, they are the same. So of course, you need to put two things together, right? So here we have service payment, we have sinking fund payment. That's an important result. Okay, as you can see from here, from 5.20, if j is less than I, using sinking fund is not a good idea because your payment is actually bigger than the payment in the amortization method, right? Or in other words, assumption under the amortization method is there is an imaginary sinking fund that could earn the same interest as the loan. Okay, that's another way to interpret. Okay, what else we have? We can also discuss the loan amount by the same method as amortization, meaning we now put service fees and the sinking fund payment together, because the first formula I gave you down here, I assume that fees are paid separately, right? I already mentioned that for each payment, I actually break it in two, right? So one of them, the one part goes to clear the interest rate or clear the interest so that L stays the same, right? And the other part is the sinking fund payment that is put into an additional account. So this is the analysis, or this is the result under that kind of analysis. Now let's do it under the standard way, meaning I consider them at the same time. So first of all, I need to pay sinking fund payment, sinking fund payment. So here I also write service payment, service payment. Okay, and this, let me use blue, is well I originally borrowed the L amount. Now I want to know the net amount at time t. There are two ways to understand. Okay, one of the idea is to study. This is the original amount. Okay, it will grow to this at time t. So now I have two payments. Okay, one is here, one is here. Both are level, right? So I need to minus the interest here is I minus sinking fund payment. Note, this is I, this is J. So that's the key. So this will give me the net amount of loan. So let me write here. It's the net, which I use NL, net amount of loan at time t. So there are many ways to understand, right? Previously, what I do is I think this SP is used to cover the interest in each period so that the outstanding balance remains the same as L. So what I need to do is to use the outstanding balance, which is a constant L, minus whatever the payments I have used towards this sinking fund, right? So this would be the amount the sinking fund will be at time t, right? So what I own minus what I have will be the net amount, right? So, but here I do it differently. So what I do is, so I don't think that the service fees, take care of the interest. What I think is, I have service payments which I can put it into a different account, right? You can think it that way. I think I create a separate account for the interest. I put it in, let's say, a service account, service fund. That account will accumulate at interest rate I. Sinking fund will accumulate at interest rate J. The SP is the regular deposit into that account. SFP is the regular deposit into the sinking fund. Of course, the net amount will be the amount of the loan at time t minus the first account and minus the second account, right? That's the net amount of loan. So there are different ways of understanding. Of course, by the end, at time n, net amount will be 0 because the loan is fully paid off. So at time n, they are supposed to be equal. Okay, try to work on this. Right? Not work on this. Try to think of the actual meaning behind it, and we already know the values, right? So you can somehow easily figure out because what's this? This is L times I. Right? So it's very, very obvious that two sides are equal, right? But this gives us another way of understanding. Mathematically, this makes trivial sense, right? They are obviously equal, right? If you do the simplification, L cancels L. This L will minus the second L. Then of course left equals right. That's more than trivial, and but the economic meaning is more interesting, right? Here you can think there are two accounts to take care of. One account takes care of the interest, the other account takes care of the principal, right? And together they take care of the entire loan. So that's the sinking fund method. We do have more examples, but I don't think there's anything I really need to work on because it's simply applying those two formulas. So let me end here. That closes chapter 5.